Hello everyone, welcome to my video here. Here I'm showing you a simple pendulum code created in Python. And so I'm using a conda environment, Qtip conda environment, to run this simple pendulum code. And so you want to make sure you want to import numpy as np and import matplot library as plt, so then you can be able to run this Python code. And so next we want to give the dimensions of the figure that we're going to plot our simple pendulum code with friction. And so using PLT figure and figure size, it's like a 8 by 8 size, and we want to add grids to our figure, so then make it look a little nice with a grid with grid lines added to the plot, and you can kind of see how it looks. And then the next step is plotting the function. So here we're going to state our x values here, which we're going to assume the position of our x is in meters, and we're going to go from 0 to 30. So we're going to let this code kind of go from 0 to 30, making very tiny, making 1,000 step size. We want this to be high value, so then it'll make a nice smooth curve. If you were to decrease this value here, 1,000 down to like 50, then whenever you plot it, the curve, the function isn't smooth. It's not a continuous smooth function. It kind of looks jagged, so you want 1,000, make it smooth. And then this right here is our function that we are plotting. And so, and you want to make sure when you have an exponential, you need to include np.exp, because that tells Python that you're using an exponential of this value right here. This is our exponential, which is x over 16 minus x over 16. Yeah, I think. Yeah. And then we have our cosine function here, which if you want to specify Python needs to know you must have this np.cosine, because that tells Python that we're using a cosine here. So make sure you get your np located right here. And this is our, and this value here, that's just our y. So our initial y point, if when x is 0, y is at 377,500. But this exponential term, this is what's going to damp our cosine function. Whenever you multiply an exponential times a cosine here, and you got minus, it's going to damp the usual sine function, the usual cosine function. I mean, it's going to damp that cosine function. It's going to bring it down to 0. And that's what the exponential function here is doing. It's going to dampen this cosine function. And then this line right here, it's going to plot x and y, which we know what our x is. It's going to go from 0 to 30, and this is our y function. It's going to plot it on the xy plot. And then these here, this is just to label our axis. So in Python, you need use X label, Y label, and title to give your XY, your two-dimensional graph, your X title, your axis titles, as well as your regular title. And then don't forget to include PLT show to actually show the two-dimensional plot. And these here, this would actually output all of the X and Y values that goes into our function above. That's going to, but we don't really need it. So that's why I put a hashtag, because we don't need it. So now we're going to run this Python code, and so you want to make sure to open terminal, and then make sure you want to go to conda, know what kind of conda environment it's in, which is Qtip, because it's locate Qtip conda environment. So here we're going to, if we type in conda info, this will tell us all the information about what's installed, all the conda environments that's installed. And so we're going to use this command, conda activate Qtip environment, because that's what we want right here. And now we have activated the correct environment. And now we are ready to run the Python code. And so this is how you want to run your Python code. Make sure to type in Python, and then you can type in whatever the title of your code is called. And don't forget the .py. And there we go. We run it, and here's our output. As you can see, that the exponential term is dampening our cosine function here all the way down to 0. So as it's recording 0 to 30 seconds here, so it's recording 0 to 30 seconds, the cosine is being damped by that exponential e to the minus 0.125 times x. It's dampening that cosine to that exponential is dampening that cosine all the way down to 0. And in the next video here that you're going to see, this is kind of analogous to dropping a ball to the floor, dropping a tennis ball to the floor. It behaves in a similar fashion. It will, when the ball hits the ground, it'll bounce up, but due to air resistance will dampen the motion of the ball coming up, so it'll lose energy, so it'll only travel so far up, and then it'll come back down due to gravity, gain some more energy, and then air resistance right here pushes the ball downwards, reducing energy, and it keeps on doing it until eventually the ball just hits the ground and it's not oscillating anymore. So, and that's what you're going to see here in the right after this video.